In this video, we're going to talk about retention replacement studies and very particularly the concept of economic service life of a good. So consider an investment, maybe a piece of equipment that needs to be bought, and it's going to be maintained over a certain number of years. And the question is, how often should we replace this item? That depends on the expenses and the behavioral expenses for maintenance and how they probably grow through time as the equipment needs larger repairs and more spare parts. And that's described in the graph that you see as the equivalent annual worth of operating costs. Also, we have the concept of the capital recovery, and that is the line that represents that, well, if you need to invest in this piece of equipment and you only hold it for 1 year maybe, and then you need to buy another one, that's going to be more expensive than if you buy it now and then you let it perform its tasks, and you don't need to make the same investment again after several years. Of course, you have the benefit that maybe you can sell the equipment that you bought at the end of the period that you decide to hold it as a salvage value. But that salvage value would help you reduce the cost of ownership. But as you so it's a trade-off between how often should you buy it, taking into consideration that if you wait too much, then the depreciation of the item will reduce your capacity to recuperate that investment. So when you consider all these factors, what you want to do is you want to keep the item just at the lowest possible cost, and that depends on how long you keep it. If you keep it for too long of a period, the annual operating costs and maintenance will keep growing, and it will not be economically the optimal decision. And if you buy it and renew the investment too often, then it might be too expensive to keep renewing this technology. So using that concept or those concepts, we create a table or create a set of scenarios. What if we own this item for 1 year or 2 years or 3 years and so on? Let's consider an example. Here we have an example in which the initial investment is for $32,000, and that is done once. The initial operating cost is $5,000. The time value of money is 20%. The depreciation at every year, well, actually it's not the depreciation, it's the remaining value is 80%. And the operating cost increment is 15% per year. So let's consider what happens in the first year. In the first year, $32,000, if we put that money in the bank at 20% of time value of money, we would receive $38,400. So for the first year, to invest this quantity is after 1 year, it's equivalent for us to spend $38,400. If we invest $32,000, now we keep it for 2 years. The annual worth of $32,000, that is 2 cash flows, one in year 1 and one in year 2, would be $20,900. $945. And if we invest $32,000, its equivalent annual cost for 3 years is now $15,191, and so on. If this item we invested in was $32,000, then the salvage value that we can get at the end of 1 year is 80% of the original investment, which is out of 32,000, 25,600. 80% of 25,600 is 20,480. 80% of 20,480 is 16,384, and so on and so forth. So that's how much we would receive only once at the end of the years of ownership. However, since we receive this money only once, we need to translate that into its equivalent if we were to receive this money, as if we were to receive this money at each one of the years. So we compute an equivalent analyzed salvage value, and for 1 year it's only the 25,600, but the 20,480 would translate into 2 years at year end, at the end of year 1 and at the end of year 2, of 9,309. And the 16,384 we will receive at the end of 3 years will translate into 3 years at the end of year 1, year 2, and year 3 of 4,501. So that way we can subtract from the analyzed cost the equivalent analyzed salvage value to compute how the cost of recovering the capital. On top of that, we have the maintenance in that year, and we consider that the operating cost is going to increment 15% per year. So the first year we incurred in $5,000 of maintenance. The second year, $5,750. The next year, $6,613, and so on. So, but those are the maintenance that occur during the year. In quantity, if we hold it, say for 1 year, if we hold it for 1 year, the equivalent uniform annual cost for maintenance for 5,000 is just 5,000, but the equivalent annual worth for 5,750 is equivalent to what that translates is, in the first year we pay 5,000, and the second year we pay 5,750. That's equivalent to 2 years, a year at the end of year 1, and at the end of year 2 of 5,341. If in the first year, now let's consider the 3-year example. If the first year we paid 5,000, the second year 5,750, and the third year 6,613. That's equivalent to 3 years at the end of year 1, year 2, and year 3 of 5,690, and so on. So when we consider the uniform annual cost for this operation, we need to consider the analyzed cost of investment, the salvage value, and the equivalent uniform annual cost for maintenance, and we can compute the equivalent annual cost that we get. And you see that for that column, the cheapest cost is when we hold the item for 7 years. That is the cost of 15,505 is the minimum value, or the minimum cost that we could get. If we hold it for less than 7 years, it will be more expensive because we have not recuperated our capital investment. And if we keep it longer than that, since we don't get as much money from the depreciation, as well as our maintenance keeps increasing, it will cost more to own this item if we hold it longer.